Okay, so this is the product rule, and this is the way it works. You have to have two quantities or two functions. Here we call them f of x and g of x. Okay, and basically the way this works is you take the derivative, like using the power rule, and of f, and multiply it by the original quantity of g. You're going to add it to the original of f, and you're going to take it times the derivative of the quantity of g. So it's not too hard, not too bad, okay? So let's just look at it. First of all, I'm going to identify, well, x squared, that's f of x, okay? And then x squared, or x to the fifth plus x, that's g of x, okay? So g of x. So now we have our two quantities. So now we're just going to follow the rule, okay? So first of all, you take the derivative of f, okay? Well, that's 2x, okay? So if we're writing our rules out here, it's 2x. We'll multiply it by the original of x to the fifth plus x. And then I'm going to add it. And I like to put brackets around just to make sure I don't mess up any kind of sign, okay? And then when I do that, I'm still following the process here. My g of x is x squared. And then I'm multiplying by the derivative, which is 5x to the fourth plus 1. And I've got my rule going here, okay? To simplify, follow through, you're gonna FOIL, so you're gonna distribute everything. So I get 2x to the sixth plus 2x squared, and then I have plus, and I'm gonna go ahead and leave the brackets. The sum, it doesn't really matter. So you have 5x to the sixth, and then it's plus x squared. And again, if you look, you now have like terms. Okay, so you have x to the sixth. So 2x to the sixth plus 5x to the sixth is 7x to the sixth. And then I happen to have a square, and that's plus 3x squared. And this is my derivative, okay? So 7x to the sixth plus 3x squared, that's using the product rule. Okay, so your turn. I want you to pause the video, and I want you to try to do the blue one, and then try the red one. It's a little bit different, and it's a trinomial times a trinomial, so there's a lot of work there, okay? So pause the video, and I'll give you the answers in just a minute. Okay, so your final answer for the first one, your derivative here, should be negative 21 x to the sixth plus 6x squared. Now, you can say, well, I can distribute through at the beginning, and then I can use the power rule. Absolutely. It's up to you. It's your choice. And your answer to this guy. And just to let you know, it's easier to rewrite this one as x to the 1/2. And then it's 2x to the negative 1. And when you rewrite it, then you can multiply through and add your exponents just like normal. And the answer is 12x to the fifth minus 9x to 7/2 minus 3x squared plus 10x plus 9/2 x to the 1/2. Almost done. Minus 5/2 x to the negative 1/2 and minus 10x to the negative 2. Okay? So this is the product rule. Just want to make a note. I want to make sure that you understand the derivative here of the e to the kx. It's a special product, okay? So it's something that you just have to memorize. There's nothing you just have to memorize it. You just have to know. Because, it kind of does function, but it doesn't, okay? So the way you look at it is if you have e to the kx, okay? E to the kx, basically, to find the derivative, it's itself, and then whatever the value of k is, okay? So if it's e to the 5x, then it's basically e to the 5x times 5, whatever this value is right there. So you could rewrite it 5e to the 5x. Sorry about that. Okay? So if we look at this one, we have the product rule here. Okay? Basically, you split it in half. X is f of x, e to the 5x is g of x, and then you proceed. So I'm going to do my derivative. I'm going to use the product rule. So the derivative of x is 1, and then I just do the original, which is e to the 5x. I'm going to add, okay, so it's x, and then it's e to the 5x, and then it's again times 5, and then to finish it out, I have e to the 5x plus 5x to the e 5x. Go ahead and write that constant there in the front, and it's no big deal. Okay, the other rule we also learned this week was the quotient rule. Okay, so the quotient rule is very similar to the product rule, and you can say sometimes it's just easier to use the power rule, but yeah, it is sometimes. You just have to figure out which way is easiest, okay? So if you have a rational function, f of x over g of x, you define the numerator is always the f of x, g of x is always the denominator. And basically this is how it works. You take the derivative of f of x times the original g of x minus, and this is a quantity, so you will want to put brackets in because it will distribute through, the negative will, by the f of x times the derivative of g of x, and it's all over g of x squared. And if you remember some of our problems earlier, there was the pattern that it always became squared. So let's try this. Okay, so again, f of x, this is g of x. And the way I'm going to do this is I'm just going to follow my rule. Okay, so the derivative of this guy is 2x, and the minus 2 goes away, times the original of x cubed plus 1, minus, I'm going to put my brackets up just to slow me down. And I know it's x squared minus 2, and it's times 3x squared. All over. Go ahead and finish my brackets off there. X cubed plus 1 squared. And I am going to fold it out and kind of give me a, so I can combine like terms and all that stuff. So I have 2x to the 4th plus 2x. And then, but I'm going to do it in a quantity and then I'll simplify it. I know this is 3x to the 4th, and then it's minus a 6x squared, and that is a 6x, okay? And it's all over x cubed plus 1 squared, and then it's final here. I know that now I can distribute my negative, and this becomes a minus, and I have like terms. So it's a negative x to the 4th, and I'm going to write them in order as well, plus 6x squared, and then it's plus 2x, and then it's all over x cubed plus 1 squared. And that is your derivative using the quotient rule. Not too bad, not too bad. Okay, so it's your turn. I'm going to let you work this problem, see how you do, and I'll give you the answer in just a second. Alright, so your final answer should be the derivative of this guy using the quotient rule. Negative 3x squared minus 10x minus 3 all over x squared minus 1 squared. How'd you do? Okay, so I know I have this on here from last year, but I'm not sure this is the exact homework. It is 158, 159. What I made them do, I'm pretty sure, was I think the first 4 are the quotient, and you can check. So 1 through 4, and then 5 through 8, and then I made them do 27, which is a word problem. And I'm going to do this right now, okay? And then if you want to take a picture of it and send it to me, that way I can give you some credit. That'd be awesome. Okay, so this is the problem I was looking at. This is how you actually use the derivative with the product rule or whatever you're doing in business, okay? So I really like the application that this shows us. So if we're investigating here, we're going to suppose that a product currently sells for $25 with the price increasing at a rate of $2. And at this current price consumers are going to buy 150,000 items, but the number sold is decreasing at a rate of 8,000 per item or per year. And we want to know two things. At what rate is the total revenue changing, and is the revenue increasing or decreasing? Okay, and this is what we have to figure out. So we need to identify quite a few things. First of all, I have revenue equals quantity times price. So yes, we need to identify everything else. So right away, our quantity. Well, our quantity that we're going to sell is 150,000 items. I'm going to use K if that's all right. And we know though that there's a change in that quantity if we up our price 2 years or by $2. And that change is a decreasing rate of 8,000. So we're going to put a minus 8K. Well, now we have to deal with our price. So our price at this right now is $25. And if we have a increasing at a rate of $2, our change here is a positive 2. Okay? So what we need to do is use the product rule. Okay? So the way we do it, our revenue change here, RT, is basically we're going to start with the derivative of P times the quantity. And sorry about my work here. I just can't get it to move here. So then I'm going to take times my original 150,000. I'm going to add it to my $25 times my negative 8. Multiply those out, so I get like 300,000 here. And this is minus 200 because of the negative there, and 25 times 8 is 200. And then I know then that my revenue, my change in my revenue, okay, when I say 300 minus, is 100,000. So you have to ask yourself, I know that my revenue is going up by 100,000. This is still positive, even though I've increased my rate by $2. So you can say it's increasing, and the rate is 100,000. Okay, so this is it. This is, if you'll go back to the homework, there is the first days, and then I did add 5 through 8. That was the quotient. We kind of split it up. So good luck, and if you have any questions, let me know.